Hey y'all, I'm so happy to be here. This is the most north I've ever been in the world, so it's really exciting for me. Quick show of hands, can you hold up your right hand if you've ever coded before? Hold that up. And then your left hand if you've ever coded a UI before. Okay, I think this is a really relevant talk for you. And no, keep them up. And if you really just want to get this over with and go to the party, just wave them back and forth. Yeah, I'll try to go fast. So my name's James. I work at IBM down in Austin, Texas, which means I am motivated by breakfast tacos and the Holy Spirit. And I joined about 3 years ago, and the first thing I did there was build a component library for the IBM Analytics business unit. It was pretty fun. I was pretty bored where I was, so that's why I started making the components, and now they're used in 13 products. Since then, I was plucked out into the design core of IBM to work, starting a year and a half ago, on a design system for all of IBM, which is a really daunting task because I don't know if any of you know, we have over 300,000 employees. So that means we're designing for that many people. And they have people that they're designing for at the end of the day. And that project's been going on so long. In the meantime, I got married, and we became parents to a golden doodle. So I have a lot of life events attached with this daunting project. I would really just like you to relax. We had a lot of great technical talks today, but I don't believe I have more than 6 lines of code in this entire project. If I do, I'll buy everyone's drinks. What I do ask, though, is that you tweet me any questions you have, because I don't think I'll have enough time for that, and also any pictures, because my mom would love to see that. So a brief history of design systems. The biggest first impact you probably remember is in 2011, Twitter released to the world Bootstrap. And they were really adamant in their original blog post that the reason they made this was because they found developers in different teams doing the exact same things over and over again that could be solved once. And I think it's a great test of time that it's still going on strong. They just released version 4. Which is a great testament to the discipline in their development community. The next big splash to me was material design. And this was the original guidebook of principles in 2014 that was released. And what they did was they set out on a mission to make sure that all experiences with Google felt like they were coming from the same company. So they made this whole spatial model about material extending past the glass that you interact with on your screen. And this was the first time a company had started their design system initiative solely based off of this issue. And since then, there's been hundreds of design systems released out there, and they all have their benefits and weaknesses. And it's really great to see the ones that are open source. And honestly, there's probably thousands more that you have closed source too. If anything, because there's so many options out there, I would go ahead and evaluate the existing options for your company. If you're in that part where you're starting to decide, should we make our own design system? And to your stakeholders and yourself, that brand value is not a real value, then I would go ahead and just do one of the other options that already exist. You don't really want to code your own dropdown. It's really easy to start a component library, but it's awful to support and improve on. At IBM, we had our own component library. I think this was when I was in middle school. But it really did keep things consistent. The problem at the time, though, was for every 60 engineers, there was one designer at IBM. And so there wasn't a lot of design governance. It was very easy to contribute a component without doing a whole UX evaluation of whether or not it was even necessary. And since then, about 4 years ago, we went on a hiring rampage and started hiring thousands of designers. We're now the biggest design firm in the world, and we're not even an agency. And what we were doing was we were taking these thousands of designers, onboarding them, and then deploying them to business units across the company. And that's a big cultural shock to all these engineering teams and product management teams that weren't used to working with so many designers. So it would be pretty controversial to introduce all these new people that are going to tell them how they think their product should look and feel, and at the same time release a fully fledged design system. Instead, we release what's called the IBM Design Language. And as a front-end developer, if you visit it, you're not going to find what you expect out of a design system. It's not going to tell you the exact type scale you should use. It's not going to have a coded component library for you to access. Instead, it's going to describe, hey, here's the relationship, the kind of look and feel that or emotions that we think an experience at IBM should evoke from the user. And it's had pretty great results. These designers that we deployed across the company have really made strides in improving the experiences they took on. And so now we're at the point where we've matured enough and these designers have great relationships with the teams they work with that it's time to go ahead and make that design system for IBM. The reason that our stakeholders are so interested is exactly the reason that Twitter was evoking about Bootstrap. The fact is, we're going to save a lot of money. While we were making the design language, it ended up inspiring 15 different style guides at IBM. And we were able to find 6 component libraries coded out already. But intrinsically, what the people working on this project are inspired by is the idea that we can have one relationship with a user for every touch point they experience IBM at. So we're hoping that this design system will actually say how a user's relationship should be from the physical event they go to the blog post they visit, to the actual product, and farther to support and billing experiences. So now that I've told you a brief history of design systems as a whole and where we're at IBM, there's 3 sections I'm going to go over. I'm going to talk to you about what's on our wish list for browsers to start supporting. I'm going to talk about a big topic that I think is going to make our design system even better in the future. But first, let me talk about the boring problems we're solving right now. So I'm sure many of you have read this blog post from Josh Clark. And it's a really great blog post that talks about how his firm goes to a company to make a design system, but they really focus on what people would consider the mundane problems. The thing about mundane problems, though, is it doesn't mean it has to be a mundane solution. The cool thing with web development is, and what some people complain about, is it changes every year. But for us, that means there's a new opportunity to solve a problem in a new way. The first example is type scale. So a lot of times in design system, you choose a type scale. This is a very dramatic type scale. It's the golden ratio, so it grows very fast. And we're not using this one. It's just an example. But if you come from a print design background, you may have been told, hey, use the type scale, go make a flyer. And it may look like this because you're starting off with your body copy size, and then you're moving upwards at each header. But what if all of a sudden your stakeholders say, okay, that's a great flyer, now make a poster version of it? Well, if you use the exact same sizes, it just doesn't look great at all. You have to squint your eyes from a distance to see the poster text. And traditionally, in print design, you're never going to keep the same size based off of the medium size, whatever the medium size is. So we can't just jump to a next header size for the poster, because all of a sudden we're breaking our design system's relationship with each size. Instead, what you're going to do is you're going to say, okay, here's the width of my flyer, here's the width of my poster. Because it's double the size, let's go ahead and double the header sizes. And that scaling is just a foundation in print design with type. So we wanted to do the same thing with web, but instead of just define sizes at each breakpoint, we realized that users are never going to be exactly at our breakpoint. So what we've ended up doing is scaling headers based off of viewport width. And luckily, somebody already found out this solution in 2016 and provided us with a calc function to pull this off. We don't do it for body and smaller, because if a user is making the screen larger, they're trying to see more content instead of its scale for body. But headers, it has this great, beautiful effect where we maintain the ratios in between every breakpoint. The next one is really great for the developers themselves. CSS variables are finally available and supported in all major browsers. And what this allows us to do is just support more workflows for developers. Sass has a really big impact at IBM. A lot of people use it. But we still have newcomers that don't want to worry about setting up their build process with Sass And sometimes variables are the only reason somebody is using SAS at our company. So if we can use CSS variables, we've just given another opportunity to make sure somebody's in sync with our design system. And again, it has great browser support, and if you do need to support older experiences, you can just say the rule without a variable first, and then the rule with a CSS variable, and you have a fallback instantly. This is the one I'm most excited about. I used to not care about grid at all, but now that we have CSS Grid, we can actually have control of both axes on the page. If you ever told a visual designer coming into web design that they can't really control the y-axis like they can control x-axis, you've instantly dashed their hopes and dreams in the digital world. So what we have here with our grid, and it's hard to see, but we have many units. They're called our fixed units, and they're always 8 pixels wide, no matter what the screen size is. And then we have 16 columns that grow with the width of the screen. And people really want to make aspect ratios because that's just beautiful. If you've ever tried to make a responsive square today in web development before CSS Grid, you probably had to use this padding bottom pseudo selector hack that required 10 lines of code. So instead of risking that one of those lines of code disappears in the future and breaks all of your aspect ratios, what we've done is we have said, okay, well, you have those 16 fluid columns. If you ever want to, you don't need to do a height based off of the fixed unit. You can also do heights based off of the columns. So if I said something was 4 columns wide, but also 4 columns tall, I know it's going to stay a square with the screen going. This is really why I'm excited about CSS Grid, and I'm surprised I haven't seen it yet in design systems. Design systems today have very responsive widths, where they probably say a button or any component fills 100% of the container width it's set in, but they haven't done that yet in heights. Now that we have CSS Grid, we can make fully what we call fluid components. And so you can see it has a height and width of 100% of its parent. And then we just set max heights and max widths based off of what the design system believes should not grow any farther. And to illustrate what this looks like, here's a traditional form you would see with those responsive width components. But then here's an example of what that form starts to take shape in with fluid components. And it's just a much efficient use of our fixed units. There's no waste of the gutter in between those columns. And overall, it's great for touch targets. And it makes the user feel like the experience they are on was designed for whatever size their device actually is. Now, there were gotchas when we were implementing CSS Grid, and I was surprised they weren't really covered that well in all of the attention CSS Grid has been given. For example, we have lots of business units that still need to support IE11. And if you ever try to use the IE11 implementation of CSS Grid, it's just not worth it. It has no auto placement, so you instantly lose the value that developers are used to when using Flexbox. Also, subgrid is still not supported by browsers. And the reason you need subgrid is because you need to actually write semantic HTML. If we don't have the subgrid rule yet, it's very hard to cascade the grid specs down on your HTML elements. And then finally, we can't control what happens inside of the grid gaps in between columns. And you're going to learn very fast that your visual designers will have instances where they do want the grid gap, but other specific items where they want to bleed content over into the gutter. And we solved all of these gotchas with the grid code we coded for our design system. And then what we did was we took our code and we tried to take out as many of the design decisions as we could, and we ended up making a node build tool for your grid code called CSS Gridish, and that's open source today. What you do is you give a config file with all of your grid's design specs in the terms a visual designer uses, and then it compiles Sass, CSS code, and a sketch file so that your designer is always on point with the same code that you're working with. and then dev documentation so you can share that grid code with others and they know how to use it. This is open source today, and I hope you enjoy it. We have examples of it using Material, Bootstrap, and Carbon grid layouts right there in its repo. So one thing we really learned never to do with our visual designers is tell them no when they come up with an idea. We always say, let's see if that's possible today, and let's see what's in the future to make that possible. Whenever we tell them no, when they give us a design, what we're doing is we're cutting off their ambition and creativity, and in the future, it just sets us up for less innovative designs. So what I'm going to go over now is a couple of things that are on our wish list that we're writing to Santa to implement in browsers. First one is variable fonts. This past year, we open sourced our typeface family, IBM Plex, and it actually comes with 3 typefaces, a sans, a serif, and a mono. And each of those comes with about, I think, 6 weights right now. And for performance, we break all of those weights into 4 files separately for a subset of glyphs, because we continue to add languages in the future, and every time we add languages, that's just going to be more files to add. What variable fonts do is they allow you to include the same weight in the same file. And that's really important because we can't just do one weight file and then change the stroke width. If you look at the animation, you can see between the weights, actual points in the design are changing. So this gives us more accurate use, but with less downloads to the browser, and overall we'll save a lot of data in that font appearing on the screen. It's coming, it really is, and we still have to look into fallback for Internet Explorer options. Next is element queries, and the reason I'm so excited about this is because it's like a media query where you say, hey, styles start at this size, but instead of it being your viewport size, it's actually any selector that you do. So I could say that, hey, a component at this size applies these styles, but then at this size it applies different styles. And this should be native CSS. There's JavaScript solutions today, but we still don't have a solution being proposed for native CSS. To illustrate what this looks like, this is our icon component we've been working on. And you can see across the x-axis is changing widths, and across the y-axis we're changing heights on it. So these are the sizes we believe it would look great to display in. But it sucks that we have to have a different component whenever the size changes and we're displaying different content. The normal button does the exact same UX functionality as the icon button, but instead we just want to hide that icon and show the text instead. If we get wider, we actually want to show both the text and the icon. If we get taller, we want to start top aligning all that content instead of center aligning. And then on our largest examples, we actually want to bump that icon into the bottom right corner. So it's crazy that we would have to have a different class name or a different entire component based off of the sizes. If we have element queries, we could use those fluid components we were talking about, and the experience would be that a developer would do their CSS Grid layout code for all the spaces that the components are going to be dropped in. They drop in those components, and they fill the space on that layout, and they naturally display the right style or layout they're supposed to. Finally, I want to talk about a topic that I don't understand why it's so controversial, which is CSS and JS. I haven't heard this much flack, except maybe for Smushgate in the web dev community. But CSS and JavaScript is just great. I've used it in like 5 projects now, PWAs, and I've always been able to get high performance scores with it. There's really talented minds that work on all these libraries. But people get, I guess, really defensive because they've always been told, don't use JavaScript for styling. I want to talk about why this would make our design system better. And I'm not even going to talk about a specific CSS and JS framework. I'm just going to be talking about the idea of applying styles with JavaScript and what it allows. So the first one is just motion. With this example, I have a drop-down with 2 options, and I have a drop-down with 5 options. And you notice, because I use transition duration in CSS, they're going to expand at the exact same time. And that's just not real life. If I fill a box, 2 boxes with rocks, the box with more rocks is going to drop faster. And so it takes you out of this real-world experience on the screen. If I actually am able to use JavaScript to do some simple math and say, hey, how many options are in this drop-down, I can calculate what the duration is going to be. And so this just immerses the user. These may not be details that they're going to recognize and complain on Twitter about, but in the back of their mind, they're visually pleased by these improvements. Next one has to do with material design and its motion choreography guidelines. In material design, they say that you're supposed to have a ripple effect on any surface when the user touches it. And that's because if you touch a piece of paper in a corner, you see shadows in that corner. You don't touch it over here and then see it directly in the middle, respond to it. And so you can't really do that without JavaScript. This is Material UI's third-party component library's implementation of material design. And they're using an event listener to ask, hey, where did the user touch this? That's where I'm going to do the animation from. And then finally, something I've been playing with a bunch lately is skeleton states. I like talking about performance UX. And you've probably seen skeleton states, although you can't see them on this light UI right here on the projection. But skeleton states are these boxes that represent content you're currently fetching for the user. The reason this is great is because it helps the user perceive that content is coming to them faster than it actually is. It buys you just a little more time of their patience. And if you read the REL model from Google, you learn that every millisecond you can get more of a user's patience is really important on whether or not they're going to drop your experience and move on. The problem is, though, that if your skeleton state always looks the exact same every time a user returns to it, they're going to notice it looks the same. And that effect is going to lose its magic. If it loses its magic, then the user doesn't perceive the data is coming any faster than it actually is. With JavaScript, we can start randomizing our skeletons. It's just Math.random added 2 styles. And in this example was a personal project I was doing. I actually randomized 3 different things. I randomized which colors the gradients come in as. I randomized what angle the gradients are at. 4. I randomized the speed of the animation. And then the 4th one is I randomized the second line of those text blocks, so it always felt like it was a different piece of text coming into the experience. So what I hope I've done today is I've shown you different ways we're currently improving mundane problems with new ways people hadn't thought about them before. I hope I showed you our wish list of things that are yet to come to help our design system solve boring problems. And then finally, why I made the case about why JavaScript really can help improve design systems. If anything, I hope this gets you out of the mind space that you need to implement a style based on how other people do it. Every year there's going to be new opportunities to find new ways of pulling off a design system. And I hope you're the first one to present that solution. Side note, I mentioned earlier we have both CSS Grid and IBMPlex open source today as byproducts of this design system. I hope you enjoy them. CSS Grid can provide grid code for your entire company to be in line with each other. And IBMPlex is a beautiful typeface. It comes in sans serif and mono for your terminals. I just found out today that the new Reddit redesign is using it. So my biggest addiction is now going to follow me from work. And thank you so much, everyone. Please enjoy the party.